Find a Taylor series for f of x equals e to the x center at x equals 0. This is actually a Maclaurin's series since the center is at x equals 0. Recall that f of x is the sum at n go from 0 to infinity c sub n times x minus a to the n, where c sub n is the n derivative evaluated at x equals a divided by n factorial. And so f of x is the sum at n go from 0 to infinity c sub n x to the n, where c sub n is the n derivative evaluated at x equals 0 divided by n factorial. F of x is e to the x, f prime of x is e to the x, f double prime of x is also e to the x, and so the n derivative of x is e to the x. We evaluate these derivatives at x equal to 0. F of 0 is e to the 0, which is 1. F prime of 0 is 1. F double prime of 0 is 1. And the n derivative at x equal to 0 is 1. Therefore, c sub 0 is 1 over 0 factorial, which is 1. C sub 1 is 1 over 1 factorial, 1. C sub 2 is 1 over 2 factorial. C sub n is 1 over n factorial, where the numerator is the n derivative evaluated at x equals 0. And so the function f of x is the series 1 over n factorial times x to the n. This is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus x to the n over n factorial plus dot dot dot. This is the series x to the n over n factorial for e to the x. To find the radius of conversion for this series, we'll use the ratio test where a sub n is x to the n over n factorial. Therefore, a sub n plus 1 is x to the n plus 1 over n plus 1 factorial, or x to the n times x over n plus 1 times n factorial. We take the limit of the ratio of a sub n plus 1 over a sub n, multiply the reciprocal of a sub n. Simplifying this limit, we have x over n plus 1, the absolute value of x. The absolute value of x, this limit is 0, regardless of what x is. Notice that x doesn't depend on n, so we move it to the front of the limit. This limit is 0, which is always less than 1. By the ratio test, the series always converges, and it converges for any real number. The radius of conversion is infinity.